All right, it is time to learn about solubility. Are you ready? Okay, so let's review first. So a solution is a homogeneous mixture, right? A solution is an example of a homogeneous mixture, not the only kind, but it's one, okay? A solution contains two major components, the solute and the solvent. So if you remember from my last video, you put the solute in, stir it up, the solvent does the dissolving, and then you get, voila, a solution. If water is a solvent, it is called an aqueous solution. So AQ after that compound. Solubility means the ability to be dissolved. It does depend on the solute and the solvent. So the type of substance affects the solubility. What do I mean? Well, you need to remember ionic, polar, and nonpolar. So polar, we have electrons that are not shared equally, so we end up with partially positive and partially negative ends. We have nonpolar, where we have electrons shared equally, no charges. And then we have ionic, where electrons are completely transferred and we end up with charges. So do you remember how to figure out what kind of bond it is, whether it's ionic, polar, or nonpolar? Remember, use electronegativity values. So you find the two elements, Na and Cl, you find their electronegativity values, you subtract them. If it's greater than 1.7, it's ionic. If it's less than about 0.4, it's nonpolar, and in between those, it's polar. But you can see from this right here, that is increasing ionic. So it's not an absolute. So something that has an electronegativity difference here is less polar than something that has an electronegativity difference here. If I'm comparing this X to this X, this one is more ionic, okay? This one would be less ionic, okay? Like dissolves like. What do I mean? Well, that means when there are charges in the substance, it dissolves well in something, the solvent, that also has charges. So let's look at what that means. So water is polar. Remember, you're supposed to remember that. If water is polar, it will dissolve other things that are polar. It will also dissolve things that are ionic, okay? If it's polar, it will not dissolve nonpolar. Nonpolar has no charges, okay? Nope. Okay, so nonpolar solutes will only, that's it, only option, will dissolve in nonpolar solvents. So oil, for example, is nonpolar. If I wanted to dissolve in something, I need to find something else nonpolar. Polar solutes dissolve in polar solvents. So water is polar, sugar is polar, so sugar dissolves in water. Ionic solutes also dissolve in polar. So anything that's ionic, like salt, also dissolves in water. So remember, polar has charges, right? A partial positive and a partial negative. Ionic has charges completely transferred, so we have a positive and a negative. So they behave similarly. So polar solutes and ionic solutes will dissolve in polar solvents. The universal solvent is water. That means most of the time when we're talking about it, it's dissolved in water. And why? Because, well, water is polar, so that means it can dissolve anything that is polar and anything that's ionic. So, you know, little joke with polar bears, careful. So again, since water is polar, ionic substances and polar substances. So no matter what kind of solute, if it's ionic or if it's polar, it will dissolve in water. Polar and non-polar do not mix. Remember, like dissolves like, so polar and non-polar, I just don't, okay? So if the solvent is polar and the solute is non-polar, it's a no-go. Likewise, if the solvent is non-polar and the solute is polar, no-go. The only thing that will dissolve in a non-polar solvent is a non-polar solute. Not polar, not ionic. A little bit of relevancy. Vitamin C is water soluble, so we gotta get it from our diet. Helps make collagen for like cartilage and bones and lots of things. We cannot produce it ourselves, but the excess, because it's water soluble, is just eliminated by our kidneys. So it can't really build up, okay, because it dissolves in water and it just flushes out. Okay, another example. What if a vitamin is fat soluble? Example of that is vitamin A. And vitamin A has to come from our diet. It's good for vision, for one example. But because it's fat soluble, that means it doesn't dissolve in water. So our blood plasma, which is water-based, it can't dissolve in there. So it kind of hangs out in our body fat, and it can become toxic if the levels are too high. Now, there are only 4 fat-soluble vitamins, A, D, E, and K, but those 4 vitamins can build up in our fat. Okay, it says at STP, which of these substances is most soluble in water? So let's remember something. Like dissolves like. Water, H2O, is polar. So that means it will dissolve anything that is polar and anything that is ionic, okay? So I have to know what these things are. Are they polar or non-polar or ionic? So what I would do is look at, in my reference table, I would look at the big one, table S, and subtract some electronegativities. So for this one, I would subtract H minus Cl, subtract those. Do C minus Cl. Do N minus N, well, I know that, that's 0. And C minus O. And I'm going to find one that is most likely going to be ionic or heavily polar, and that's going to be my answer. Something also to remember, CCl4. So it looks like this with C and then a Cl on each side. So if I find that this bond right here is polar, because these are evenly distributed, the molecule is going to be nonpolar, okay? Same with this one. So it is C bonded to O. These are ones that you should remember. So like this. So even if this bond is polar, the molecule is non-polar. So a couple ways to approach it, but you should get to this. Hexane and water do not form a solution. Which statement explains this phenomenon? Well, here's kind of what it's talking about, but this is oil and water. So why does it not form a solution? Well, do you remember? Well, is water non-polar? No, that's wrong. Water is polar. Water is not ionic. So if hexane and water do not form a solution, that must mean hexane is non-polar and water is polar. Okay, ionic solids will most likely dissolve in, well, ionic solids have charges. Okay, so they would dissolve in something easily that's ionic. That would follow like, dissolves like right away. But it will also dissolve in something else that has charges. And what also has charges? Polar things. So I know it's not going to dissolve in non-polar easily. So I should get rid of those. So I know it has to dissolve in something that's polar, and you should remember this, that water is polar. Okay, solutes, so the thing you're putting in, right, that can be a solid, a liquid, or a gas. we're going to focus on liquid solvents, so we're not going to really investigate outside of that. So gas solutes can dissolve in liquid solvents. Soda, seltzer water. Pressure affects that solubility. So let's look at that. If I increase the pressure, it increases the solubility. I can squeeze more in, okay? So by increasing the pressure, I can force more gas molecules into the solution, and that increases the solubility. So you can tell it's under pressure to keep the gas bubbles in the solution, because when you open it, it goes, psh, some of the gas escapes as soon as you release the pressure. How do you release the pressure? Open the container, okay? If you have shaken it ahead of time, you could end up with this mess, okay? Or this mess, okay? If you're opening something that you shook especially, okay? Because you're forcing more of those gas molecules into that little tiny space, so when you open it, they come out with greater excitement. Now, for a gas, if I decrease the temperature, I can increase the solubility. So that means a warm soda is going to let more gas molecules escape, going to have lower solubility. A cold soda will hold more of the gas molecules in the solution. It has a higher solubility. So you can see when I have a gas, okay, as I increase the temperature, the solubility decreases. So looking at this whole big table, I can find ones that are most likely gases by looking for the ones where the solubility decreases with temperature. So again, if you have a carbonated drink that's in the bottle at high pressure, you don't really see the bubbles because they're all forced hanging out in the solution. As soon as you release the pressure by opening it, all of a sudden you see bubbles, they start to leave. Again, times this, warm soda will taste flatter. So if you pour it when it's warm, it's going to taste flatter because there's less stuff dissolved in it. Okay, again, if I increase the temperature, the solubility of a gas will go down. Under which conditions of temperature and pressure is a gas most soluble in water? Okay, so if I want to get the most gas in the solution, what do I need? Well, I don't want the temperature to be high because I know warm soda tastes flat. Okay, now let me think. So before I open it, it has more dissolved, and that is when the pressure is high. So low pressure is wrong. So voila, there's our answer. A capped bottle of cola contains carbon dioxide gas under high pressure. When the cap is removed, how does pressure affect the solubility? Well, when the cap is removed, the pressure is decreased. The solubility of the gas immediately decreases, so more carbon dioxide leaves the solution. What about liquid solutes and liquid solvents? Well, we use these words miscible and immiscible. Miscible means they're mixable, and immiscible, not mixable. So miscible, 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 miscible. Okay, what about immiscible? Immiscible, immiscible. So if those had multiple things in them, those would be the things that would be miscible and immiscible. What about solid solutes in liquid solvents? Okay, remember this one from back? If I increase the surface area, meaning use little pieces, I can increase the rate of dissolving. Solubility of solids in general is going to increase with temperature. So as the temperature increases, the solubility increases. So in this solubility graph, this chart right here, most of the things are solids because you can see, look, solubility increasing as temperature is increasing. Now, not all ionic compounds are soluble, but even when they're insoluble, according to this chart, a little bit is going to dissolve still. So when ionic compounds are dissolved in water, they dissociate. They break apart into their ions. So for example, NaCl dissociates into one Na and one Cl, dissolved in water. How do I know it's dissolved in water? UCAQ. This one, calcium chloride, dissociates into one Ca, but two Cls. Okay. When molecular compounds are dissolved in water, they don't dissociate. It'll stay stuck together. Okay, so salt, you can see, dissociates, separates into its positives and negatives. Sugar stays stuck together as sugar. So when molecules, remember molecules means covalent or molecular, when they dissolve in water, the particles stay together. They're surrounded by water, but they don't dissociate. The solubility of KClO3 solid in water increases as what? Well, if it's a solid, then I should know that pressure is irrelevant. And remember this, gases versus solids. Okay, so when will a solid have increased solubility? Well, when the temperature increases. And there you have it. That is solubility. I hope you learned something new today.